Hi everyone. So I want to show you some of the solutions, the homeworks, and I want to concentrate on modular exponentiation because I will also have a quiz on that. I find that important that you know how this works because it's really one of the keys in calculations that we will do later involved for our cryptographic purposes. So how does it work? All right, so the example that I wanted to do was number 28. In the book, they use the so-called algorithm 5, which combines the two calculations, whereas when I explain it, I kind of separate the calculation. And I'm going to do this again. I'm going to take them apart. I find that easier for me to organize everything. Because mistakes are easily made. In fact, I started this problem in a previous video that I made, and I made a mistake, so I had to redo it because it's so easy to make a mistake in these things. One calculation, and because the next calculation is built on the previous calculation, so one mistake and the whole thing is wrong. Okay, so here's what we do. It's 123 to the power 1001 mod 101. 101 is actually, it's a prime number, which makes it easier to calculate. In fact, in the next session, we're going to see that this can be done way, way quicker. And in fact, I already know the answer just by knowing that extra technique. Normally, I would have to do more work, but this is a special problem that it gets very difficult if you just do the method that we're going to do now. So for now, that's what you have to do. All right. So, So what we do, step one is, we first have to analyze that exponent, so 1001. So let me, this is this exponent here. And I have to write it as a sum of powers of 2, okay? So which powers of 2 do we need? Well, we have 1, 2, 4, 8, 16, 32, 64, 128, 256, 512, 1024, 2048, but we only have to go as high as our number. And the technique of finding the binary expansion, there are two techniques. The one that we see in the textbook that works for any base, where you just keep doing the division algorithm by 2, and you keep recording the remainders, and these are then the digits, but the only thing to be careful about is the digits from right to left. But there's another technique that works in general, but it's much harder. But for binary, it's very simple. You look for the smallest power of 2 that is, the biggest power of 2 that goes into here. So that would be 512. Okay? So we have 512, and what is then remains? So we have 512, and what remains is 9. I better don't make a mistake here. Right, I'm sorry. I don't want to do too complicated things in my head because that's why I make mistakes. So there's 489. Of course, this number is going to be now smaller than 512, so I'm looking for the next one that goes in there. That's 2556. So the 489, this will be, so this one will now be 256 plus, and what is remains then? 233, right? Now, 233, I can put a 128 in there, so this will be, so this is now 128, plus, and what remains is 105, 4, 8, 9, okay, this is, let's say 105. 30, yes, 105, right? Yeah, okay, 105. Okay, 105, that in turn is 64 plus. So I'm always going down my list here of powers, right? 64 plus what is that remains? 41. Okay, so 41, that is 32 plus 9. Now 9, no, so here's the first time that some of the powers, so 32, but 16 and 8, 16 doesn't go in there, so but 8 does. So this is 8, and then what is left is 1, and that is already a power of 2. So I don't need to do anything anymore. So I get 512, 256, 120, 64, 32, 8, and 1. And for some reason, I don't trust myself. So what I'm saying is that this, we have 512 plus 256 plus 128 plus 64 plus 32 plus 8 plus 1. Now, I just want to double check because I don't want to make a mistake again. 512 plus 256 plus 128 plus 64 plus 32 plus 8 plus 1 is 1001. Okay, that is correct. Okay, so this is the first step I've done. I've written 1001 as sum of powers, and the reason that I do this is I remind you because so let me do this also in yellow. So imagine that you replace this yellow expression by this sum. Now this is an exponent, so what happens with if you take a sum of exponents, that is the same as multiplying each of these powers, 123 to this power, 123 to that power, and so on, and then multiply together. That's what we're going to do. That's step 2. And so in step 2, we do two things. At the one hand, so perhaps I'll make a little table out of it. Let me get rid of a bit of this here. We have this, calculate this now. On the one hand, here I write the powers of 123. 123 squared. And each time I take the square of the previous one. 123 to the fourth, 123 to the power 8, 123 to the power 16, 123 to the power 32, 123 to the power 64, 123 to the power 128, 123 to the power 256, and 123 to the power 512. And that's the last one because that's the last, the biggest one that I need. So, and how do I get from here to there, and from there to there, and from there to there? Each time I square. That's the rule of exponents, right? Squaring this thing would say that you double this exponent. So that's exactly what happens. On the other hand, what's gonna put on the other side here, on this second part, here I'm gonna work modulo 101. Let me write it this way. No, I shouldn't do that. Sorry, that's stupid. Okay, let me not write this line as in one. So this, what I'm gonna do here, this will be modulo 101. Okay, so let's start with 123. 123 to the power 1, that's just 123, but I can already reduce that. And small numbers is easy to reduce. You say it's 101 plus, what's the remainder? 22. Okay, so this is the remainder, but okay, let's write it. It's equivalent to 22 mod 101, but I'm not going to write the mod 1 and 101 anymore. And remind you how do you calculate this. Either you use the division algorithm like I did here, you find the remainder, or you just use the function 123, so what this number here that I just calculated, this is of course 123 mod 101. Okay, so these are the numbers, this is what this column will be. Okay, so then I take that number, and because these two numbers are the same, therefore if I square them, they will also be the same modulo 101. So I take the square here and take the square of this 2, that will be 22 squared. 22 squared, 22 squared, 22 squared is 484. Now, again, I can do it using the mod function, but I see quickly here that it's 4 times 101, that's 404 plus 80. So I know that this is equivalent to 80. So, one more time, this is the same as that, so if I square this one, I can square that one. And so I get 80 squared, which is 6,400. Now 6,400 is 63 times 101, which is 6,000, this number is 6,063. So what I'm missing is 37, right? So 37, so this is 37, okay? Let's do this intermediate, sorry, no, that's not, okay, sorry. Sorry, I wrote this wrong, let me write this correctly. This is plus 37, so this is equivalent to 37. 63 plus 37 is 37, okay? The next one, so 37, again, I feed this number, I use this here, 37 squared, that is 37 squared is 13, that's 1369. So if I divide that by 101, I get 13 points, so that is 13 times 101, which is 1313. And what is left then? So 1369 minus 1313, that is 56. Okay, again, here we go. This is 56. I square 56. So 56 squared is 3136. 3136, and now I have to calculate this. So 3136 divided by 101, that is 31. So that is 31 times 101, which is 3131, and that is 5 left. Right? This is 3131. It's easy to 101 is actually kind of an easy number to work with, and so what I'm missing is 5, right? So this is 5. Okay, so let me not write this anymore. I take this 5 and square it. So this is 5 squared, which is just 25, which is already reduced, so no work here. Next one is 25 squared, which is 625. So that's, okay, that is 6 times 101, that's 606. And so what I'm missing is 19, right? So plus 19, so this is equivalent to 19. Okay, let me get rid of this number. Now I square 19, so 19 squared. Okay, that one I have to do. 19 squared, that's 361. That is 3 times 101, and that's 303. And so what I'm missing is 58. 303 plus 58 is that, so that's equivalent to, to 58, correct. And then finally 58, no, not finally, 58 squared. We keep going, 58 squared. No, that's 3364. 3364. So this is 33 times 101, which is 33. So this number, sorry. I wrote it equal here, that's not where I want to write. There's something still missing, right? The remainder. So 33, and so what I'm missing is 33. What I'm missing is 131. Okay, so this is equivalent to 31. Okay, let's get rid of this intermediate calculation here. And then finally, now I have to take this number and square it. So 31 squared. 31 squared is 961. 961. And what is that? Well, that is 9 times 101. That is 909. And then what is missing is 52. Okay, so this is equivalent to 52. Good. Now, what do we do? So this is step 2. Step 3, now we have to put it together. And that is, this gives us the recipe of which powers we need. We need, I'm going to do this in orange perhaps. So each of these powers, I'm looking for each of these powers as occurring as exponents. So this 512 occurs here, the 256, the 128. Now look, just for, this is what I'm looking for, right? These numbers, so 64, 32, then 16 doesn't appear, so I'm not going to use it, but 8 does. And so let me keep marking this. So 64 power, 32 power I need the power 8, and I need the power 1. So what this now mean is all the things that I marked, these numbers here in the back, those are the ones that I'm going to all multiply together. Right? Remember, these are exponents, so the sum of exponents is the product of the power. So I'm going to take the product of all these numbers, which means that I'm going to take the product of, so our answer is going to be 22. I'm taking this number, and then I take this number times 56, and then I take this number 25, and so etc. 19 times 58 times 31 times 52. Now again, the problem is if I multiply them all out together, this is a huge number, so my calculator cannot handle this. Of course, the point is that it's actually still calculated model 101, right? It's still model 101 that we want. So this is equivalent to that model 1. So I'm going to have to calculate each of these products, and I'm going to do this one at a time. So let's, I'll color them a little bit. So let's do the next color, red. So these two, what is that? Well, 22 times 56, that is 1232. This is 1232. And that is the same as 12 times 101 plus 12 times 101 is 1212. So what I'm missing is 20. Okay, so this is the remainder mod 20. So so this is what I'm saying. 22 times 56 is 20. Okay, I can now, it is faster actually if you now take the next pair. There's a couple of ways you can do this. I'm not saying this is the only way, but let's do it this way. It's perhaps a little bit easier to do 25 times 19 for you to follow what I'm doing. That is 47.5. This is 475. That is 4 times 101, which is 404, plus 404, so 71. So this is 71. Okay. Let's take the next group. Well, there's only, well, sometimes it doesn't always group together. So 58 and 31. It's 58 times 31. That is 798. So this is 1798, which is 17 times 101, which is itself plus something, right? I have to still write, but this is 1717. So what is missing is a 1 here and an 8 there, 81, right? 8, 9, yes, 81. So that's the result. Okay, so this is kind of not correct if I write it that way, but now everything is correct. This is 81. So this is the remainder. I'm only looking at the remainder. So now this means that this number is also equivalent to the remainder. The red one combines to 20, the pink one to 71, the green to 81, and then the 52 was just on its own. So I can repeat this now. Okay, so I'll group these two together now. Let's take this color again. So 20 times 71, that's 1420. So this is 1420. That is 14 times 101, which is 1414, plus 6. So this is the remainder, 6. 81, let's do this in a different color. 81 times 52, what is that? 81 times 52 is 4212. So this is 4212. That is, we have to be, this one I cannot do out of my, wait, sorry. What was it? Okay, 81 times 52. Okay, now divide that by 101, that is 41 times. So this is 41 times 101, which is plus something. I still have to find out what the something is, but this is 4141. So what I'm missing is 12 and 59, so 60, 71. Right, is it correct? 11, 2, 11, 1. Yes, that's correct, 71. So that's the result of these two. And so now finally I have to multiply. So this is equivalent to 6. The two green combined to 6. The two red combined to 71. So that is equivalent to 6 times 71 is 426. So that is 4 times 101. So this is 4 times 101, which is 404. And what is missing therefore is 25. And so my final answer is 25. So this is again mod 121, mod 101. So this number I'm claiming is 25. Now I want to double check this, and sometimes I make mistakes somewhere in the middle or at the end. So how do you check this? This is something you can. When I ask you this on a quiz, you have to show me all this work, right? And then you have to do these calculations. You have to show me. You cannot just use the mod function. You have to show me how you calculate these things using either. So this is the two ways of calculating this thing. You can either use the division algorithm that gives you the quotient and the remainder, or you can use the step in which it's basically the same. You can first calculate 123. You first calculate this number diff to 101, and then you use the diff to calculate the mod. Okay. Anyways, so all this calculation, but now once you have this, you can double check this. So the number that we have is I use Wolfram Alpha, and Wolfram Alpha understands these things. So you see, it's something else. It's almost that I need. Sorry, the power was 1001. Okay, so notice that if I do this, double checking that is well, for the first input, is this what you wanted? 123 to the power of 1000, 1 mod 101. Exactly what we wanted, and the answer is 22. And is that what I got? No, I got 25. So somewhere I made a mistake. I'm so sorry. Well, I see already the mistake, right? Because what I was doing here. This was 1212. No, that's 20. That's correct. And this was 401. That is 71. Well, let's see whether I got my powers right. If this number is not correct, then I made a mistake somewhere there. So I'm first calculating 123 to the power 512. Okay, that's 52. That was correct. So that's not my mistake. So my mistake was in putting these two together here. So 22 times 56. Let me double check my numbers. 22 times 56. 22 times 56. 1232. Yeah, that's 1212. Yeah, that's correct. 25 times 19. 25 times 19 is 475. That's 401. Missing 71. So that's correct. And then 58 times 31. 1798. That is 1717. Yeah, I think this is also correct. So what did I do wrong then? 20 times 71 and 81 times 52. I didn't copy anything wrong, right? 22, 56, 25, 19, 58, 31 and 52. 20 times 71. 1420 divided by 101, 14, okay. So, okay, that is 6. And then the other one, 81 times 52, 4212, that is 4141. Or perhaps that is where I went wrong. 4012 minus 4141, that is 412 minus 4141 is 71. No, still correct. What the hell did I do wrong then? 71 times 6 is 71 times 6 is 71 times 6 is 426. That is 404. Oh, this is 404. Wait, what did I say? Well, it's the very, very last step I made a mistake. It's 4 times 1, so this is 404. So what is missing is 22. And that's the answer, right? Yes, sorry. It's just a very last. I was getting really tired. And yeah, so this tells you have to be careful. It's very easy to make a little mistake like that, and I will of course give you partial credit if the mistake is minor, but I cannot see whether you made a mistake, a minor mistake, if you don't give me all the details. Okay, so the second problem was I asked you to write this number 5962 in ternary. And so remember, there are several techniques, but the technique that I want you to use is start using the division algorithm, divide by 3 each time. So 4962 divided by 3, that is 1654, remainder 0, because, sorry, times 3 plus 0, because it is actually divisible by 3. What does that mean? Well, that means that the last digit will be 0. So what do you do now? Which number you take? 0? No, of course not. You take this number now. Be very careful, right? 1654. And now you're going to divide this by 3. So 1654 divided by 3, that is 55 1 times 3 plus, and what's the remainder? So 551 times 3, that's 53, so 53, that is 1. Okay, then you take this number, 551, that is 551 divided by 3, that is 813 times 3 plus, and what's the remainder? So 183 times 3, that is 549, so the remainder is 2. Then take this number, 183 divided by 3, that's 61. So that's again, that is 61 times 3. Is that possible? Of course. That just means that we're going to have another digit 0 here. Take your next number, 61 divided by 3. That's, of course, now we can do this by hand, in our head, right? That's 20 times 3, 60 plus 1. So we take 20. 20 is 6 times 3, which is 18, plus 2. We take 6. That is 2 times 3 plus 0. Don't forget to write the remainder, even if that's 0, because these are going to be our digits. Okay, you take 2, and now divided by 3, that is 0 times 3 plus 2. And then, of course, if I would take this one, I would get 0, 0, 0, 0, 0. So even if you keep going, it's still correct, because you're going to go on all zeros. And remember, you list everything now from, you go this way. So this is the right digit, right, and this is left digit, right? So this will be 2, 0, 2, 1, 2, 0, 2, 1, 0 in ternary. Okay, so I repeat, I go this direction. That's one mistake people sometimes make. You go, this direction. Okay, so this is going to be the last digit, this is going to be the first digit. Okay, that's in ternary. We do the same for base 7. So in base 7, the number was 4962, right? And so we keep doing, we keep doing the division now by 7. So 4962 divided by 7, that is 708. So 708 times 7, and what's the remainder? So 708 times 7, that is, so this number is 4,956. So what we're missing is a 6 here. 6 more, that's the remainder. Okay, now this I don't need. This is not important for me. What is important for me is this number. And I'm going to divide this now by 7. So that is 101 times 7, that's 707 plus 1. Okay, then we take 101 and divide it by 7. So how many times does 7 goes in 101? So 101 divided by 7 is 101 divided by 7 is 14. So 14 times 7, which is 70 is 98, and so the remainder is 3. Okay? Right, so where am I here? Let me get rid of this guy. We take this number, 14, we divide it by 7, that's 2 times 7. There's no remainder, well, that's 0. Then we take 2. 2 is 0 times 7 plus 0. You have to do this last step, because otherwise you would not, it's 2, what I'm saying, 0 plus 2, right? This is going to give you last digit, right? The first digit, sorry, I misspoke. So again, we write this from in this direction, so it's 20316. That's our number in base 7. Now that's just to practice this a little bit. As I said, it's the first problem that I'm going to quiz you on, and I will give you a separate review for that.